Sure. Thank you very much. And good evening, IoT Village. So it's great, really, to be here with you. And I really enjoy the fact that I'll be under attack of digital viruses or real one. Show must go on, and we're all here. That's fantastic. So my name is Aleksander Gorkowienko. I work for Spirent Communications. I'm a part of SecurityLabs team, and I am specialized in security of industrial control systems. So today, obviously, we will be talking about ICS and SCADA in security. So let's start from basics. What those industrial control systems are. So this is modern technology, a piece of modern technology used to control a variety of technological processes. It could be industrial processes, manufacturing, power generation, all critical national infrastructure, electricity transmission, oil and gas pipelines, transportation, you name it. All those places where we have systems, industrial control systems. So they are a bit special. Yes, we know about IT, so let's talk about OT now, right? Operational technology. So those systems are quite often they are proprietary. They have very, very long service lifespan, sometimes really beyond 20 years. If you do a factory acceptance test for nuclear power plant, it might take like 3 to 5 years. So once it's there, it's there, right? So obviously, considering this, many of those systems are not easily upgradable, and some are not upgradable at all, because you might have this little device, it works for 10 years, and well, the vendor is not with us anymore, but device still works, so why bother? Those devices might have a variety, they feature a variety of specialized communication. They have many legacy protocols, but also those legacy protocols, they historically just been used for many, many years, just by wired, and now they just all nicely wrapped in modern TCP or UDP. Those systems built 15 or 20 years ago, they were not designed with security in mind. So from the modern perspective, they are very, very nice and hackable. So typical ICS architecture. So we have two realms. We have a corporate network and we have control network. So on those corporate networks, we have all those viruses, clicking wrong links, etc. So all those problems really known to system administrators, and this is literally living a modern nightmare. And on the other side, we have control network. This is where we have field devices, we have robotic systems, we have production lines, we have all hundreds of sensors, actuators, etc., etc. So obviously, the last thing we really want is to introduce those modern, perfect vulnerabilities well known to IT world to the operational technology. So that's why we have a variety of ways, modern ways, how to separate those two worlds, but at the same time, because guys from the corporate network, they still want to have access to the control network, to have access to statistics, to information about how those processes are running, etc. So still there should be some connectivity, and this might be like smart industrial firewalls, and then maybe even one-way traffic managed by data diodes. So there is no ultimate solution for now. So again, this is one of the biggest problems, and quite often the separation between IT and OT is called air gap. So air gap systems, that's what we will be talking about today. Is ICS and SCADA secure or not? Well, it's a rhetorical question, really. I would say rather not, but it's up to you really to answer this question. Just a couple of facts, purely from my point of view. So ICS and SCADA is, first of all, it's just managed by engineers, not IT. Engineers are really smart guys, and I know myself many of them, and they're really, really smart. They can build from scratch insanely complex, fantastic systems, but quite often, with all respect, they don't have good understanding of basic security, cybersecurity, and this leads to issues. So legacy systems quite often work side by side with the newest solutions, and that's why we have a typical problem with enforcing unified security, something which, and again, if we have a system, we have no choice but to make it working together. So quite often the only solution is to lower the security level of the newest solution to make it compliant with what we already have. SCADA systems are much more vulnerable to denial of service. to such extent that you can't even run Nmap scan against a live system. So forget really live testing of ICS SCADA environment, really. So you have to really know well those systems to be able to test cybersecurity. I mentioned already that many critical systems feature proprietary protocols, and they are designed long ago and operating in non-secure way. So no encryption, no any well-known security features as we know them these days. So if I can make it like a bottom line of this, is probably quite often we're dealing with something called security by obscurity. So if you know how to poke and what to look at and how to look at, it's all in clear text and it's all very easy to get, very easy to reach. So from the attacker's perspective, this is something called myth of security by air gapping. So again, OT ideally should be separated from IT, but it's not possible by the way it is designed and by the way it is managed these days. So one of the key and very most interesting problem or exciting problems for attackers is how to break this air gap. Exploiting ICS actually may be much more than exploiting a web server. I can only refer here to Bruce Schneier, who at DEF CON last year, he said that the IT security problems actually coming to real world and coming for good. So IT security problems are not in this in the digital world anymore. They are coming to real world, and this is where the consequences could be literally lethal, could be very tangible, very physical. So it could be damaging infrastructure, affecting the safety and security of people. So how you can break the air gap? Yes, so obviously you can think, yeah, we can sniff those famous 1EC fields. We can do sniffing in the air of all type of wireless communication. We can play with out of band channels, etc. But believe me or not, all good old ways such as malicious USB sprinkling, hacking through supply chain, which is also quite an interesting thing, and all those things they work really, really well. So it's not necessarily you should jump over the fence and try to infiltrate or hack the nuclear power plant. It's much easier actually to hack the supplier of PLC device, the device which will be used in the power plant. So there are different ways how to get in. Another very famous thing is just using the technicians and field engineer laptops. Quite often they are not updated at all, or updated like 10 years ago. So you might expect that their time stopped like 10 years ago, and you have all those PDF readers all perfectly vulnerable with unpatched operating systems. So these days it just you go there with modern exploitation tools and like child in the toy shop. And obviously you can sniff communication, wired radio communication, etc., and also attack unmanned field site, which is also quite interesting because these days they have very good communication with central office and wireless communication, but they might not be properly secured. So it's a good and easy way to get into the network. Another interesting type of problems we are dealing with is that we have a new brilliant generation of ICS remote clients. We have web applications and mobile applications used to manage industrial processes. And yes, that's fantastic because we can sit in our room, in our house, and manage complex technological process thousands of miles from us. But at the same time, the problem is very serious because we are introducing to the OT world variety of well-known problems from the web applications or mobile applications, such as SQL injection, cross-site scripting, direct object reference, LFI, RFI, whatever. So all which is well-known, we know how to exploit it, we know how to hack it, and now we have all those things managing critical industrial processes or critical national infrastructure. So what tools and skills does an attacker need to be able to exploit those networks and ICS systems? So again, because modern ICS and SCADA systems, they are more and more featuring TCP/IP. So surprisingly, you should not be necessarily too much even specialized in this thing. So you can play, if you're good with infrastructure security, you can start playing with security of industrial systems. You need to have tools for network sniffing, traffic analysis, reverse engineering. Obviously, you need to be able to script packet crafting, so Python or any programming language you like. You need to ideally to be familiar with hardware for connecting to ICS systems, actually to connect, to deal with wires, to sniff on signals on wires, etc., etc. And yes, enough time and curiosity surely would help. I want to tell you about a very interesting example of how we hacked something called FPSO. I don't know if you're familiar with what FPSO is. FPSO is a massive, huge vessel. It's called floating production, storage, and offloading system. So it's something which is used by offshore oil and gas industry. So it's a ship, and it just stays. It floats near the offshore drilling platform, for example, and it provides necessarily all devices and chemicals needed for drilling, and also collects crude oil and even pre-process directly on FPSO. So it's like a oil processing facility, floating oil processing facility. This is how it is connected. So actually we have pipelines connected to drilling platforms. Drilling platforms are anchored and they're just taking oil from there, and it's transferred to FPSO. So we did an assessment of IT and OT on the vessel, and we came to quite long and a very interesting report. And as we are limited in time today, I just want to focus on most interesting things from here. Is first of all, obviously, is breaking the air gap, and how we managed to access and hack the air-gapped HMI server, and also tell you a bit how we utilized and how we featured man-in-the-middle attack to hack PLCs, so programming logic controllers, and also use the same approach to hack NTP server. So let's first of all talk a bit about the hacking the air-gapped server. So that HMI server, right? HMI server was located in a heavily protected area. It's like the cabinet with finger-thick metal, probably able to withstand nuclear blast. So you can't get there. Once it's there, it's there. And from there are thousands of connection lines and to PLCs, and those PLCs are controlling this very complex drilling and oil processing machineries. It's hundreds of processes controlled by this system. The only way to connect and to interact with HMI server was over fiber optic KVM. And on the other side, so the FPSO control room, you can see we can have the obviously the KVM box. You have a screen, keyboard, and mouse, and that's it. Nothing else. And physically, FPSO control room and the HMI server were located in completely different places in the vessel. So we tried to play a bit with this HMI server over KVM, and we immediately identified that this is Windows 7 installed there. It is unpatched, and there is no AV, which is fantastic. HMI is supposed to be working as a kiosk with no access to the operating system, but we were able to overcome it literally in 5 minutes. So we found two things there that helped us to exploit the thing quite easily. So first one called notepad.exe, and second one called certutil.exe. Anyone knows what certutil is? So certutil is a tiny tool, tiny executable, which is part of default installation pretty much of every Windows server or workstation. And this is just a small tool used to deal with certificates. You can convert them to different forms. You can install, uninstall, etc. Important is for us that this little tool can do a very important thing. It can convert an executable to a base 64 encoded text file, and vice versa, to convert base 64 encoded text file to a normal executable binary. That's exactly what we need. Because the same thing is on our machine, on the hacker's machine, and also on the HMI server. We also use something called Bash Bunny, so probably everyone knows Bash Bunny. And in our case, we were using it as almost like a keyboard on steroids, I would call it. So we use it instead of the whitelisted keyboard. So we couldn't use any keyboard stick to the KVM because the device IDs were whitelisted. So we had to program correctly Bash Bunny so we can mimic exactly the exact USB device, and it was Dell keyboard with specific UID. So how we managed to transfer the potentially malicious binary or our tools to the HMI server? So let's start from the actions on the attacker's computer. So we have the binary file we want to transfer. We use a certutil executable and we convert it to the base 64 encoded file. You can see it on the screen. So it's just normal text file. You can open it with Notepad. Then we convert this text file using our own small Python script to a set of instructions for Bash Bunny. And Bash Bunny was used as a keyboard, simulating keystrokes. And what we did, we actually opened a Notepad on the HMI server side and literally typed the base 64 encoded file of our binary character by character using Bash Bunny. And once we have it there, once we have it on the HMI server side, then we can reverse the whole thing using certutil. So we can run it, given as a parameter, the file with base 64 encoded binary, and then we have our binary recreated, and then we can run it, and we can do anything we want. So job done. Now, another question is, so that's fine, yeah. So by using this method, we can transfer pretty much anything to the HMI server. Now the question is how we can transfer something from there, because I can't stick USB stick to the KVM. It wouldn't help because the HMI server wouldn't see it. So we thought about very interesting and actually simple way. So we transfer there a small custom build utility to the HMI server, which converts any executable or any file, anything you drag and drop to it, to the code, to the QR code. So once we have a QR code on the screen of our KVM, then we can use even simple QR code scanning application on the mobile phone, read it, and then restore the content. And this could be text file, could be configuration file, because there were many interesting things on the HMI server. There were configuration files with plain text credentials. The whole system was written in C#, and obviously everyone knows that it's perfectly reversible. So there were lots of interesting files we could take back and analyze, let's say, offline. So by this simple approach, we could take it from there. Now let's talk a bit about man in the middle. So I think everyone knows what man in the middle is, and now a bit about how this could be applied to the industrial systems. So yes, we have a switched network, we have a router, we have HMI, and we have PLCs, actually many PLCs connected to the router somewhere, and we have, let's say, attacker also connected to the same network somewhere. So PLCs are communicating with HMI every, I don't know, 10 or 50 milliseconds, and they're transferring tons of data. They're updating status of different temperature, pressure in hundreds of different control points, etc. It's very important that from the HMI point of view, there is a constant stream of information. You can't stop it, and if the wrong value is in the wrong place in PLC, then the system will automatically execute shutdown because it might be just like emergency shutdown. So it's quite interesting thing, because what we can do now, because we can use typical ARP spoofing. So we can send ARP messages to the network and reassociate IP addresses of HMI and PLC with MAC address of the network card of an attacker. And now it says from now on, this IP address is associated with my MAC, and also the other IP address is also associated with my MAC. And if the router is simple, there is no any protection there, well, the devices say, yeah, that's fine if you say so. So from now on, the whole traffic goes through you. And once it goes through you, obviously you can do whatever you like, right? So once we have full control over the network traffic, we can not only sniff and passively collect all sensitive information about what is going on in real time. We can also tamper this information. We can, for example, not only read registers from PLCs, we can also write information to it. And again, this is quite important because we can simulate or trigger emergency shutdown of the system by, I don't know, sending some insanely high pressure level, which is just a normal value, just a numeric value, sent to the right cell or to the right register in the PLC. Another way to play with the man-in-the-middle attack is to attack an NTP server. As I said, on the ship, we have many devices, and again, this whole machinery is insanely complex, and many things and many sensors and actuators. First of all, they are orchestrated with precision up to a second, and obviously this requires for hundreds of devices to have exact and correct timestamp to be provided. So if difference is higher than, I don't know, some certain threshold, like a couple of seconds, then the again, system say that something is wrong, and the only thing it would do is just do emergency shutdown. So by playing a man-in-the-middle in this case, so we can introduce the incorrect source of information. The correct source of information obviously is a satellite. It comes to the GPS receiver, which is something called stratum. So stratum is like level of trust, right? So the level of trust. A satellite is the stratum 0, so the ultimate time source, and then the highest in the hierarchy is stratum 1. So it's this GPS on the ship. And all the other devices are lower. So if we introduce any other source of reference time information, and this time information would be different, let's say an hour different, or even a couple of minutes different, then routers would detect it, and the whole protocol is built the way it will just put this to the blacklist. It says, you know, this you're just saying really rubbish, right? This cannot be this time because it compares with previous one, and if the difference is too high, just ignores you. So we thought, okay, so still can we exploit it or not? And we found the solution. So instead of giving completely random and insane time values, we can take the existing time value and increase it a bit, just let's say to 1 second, or let's say for the sake of this example to 3 seconds. And this means that we are still in this window of acceptance by the hardware. And what we can do now, we can increase it a bit again. So the difference to the previous value is 3 seconds, but to the real time is bigger. It's 5 seconds now. So we're still in this window of acceptance, and we can very gradually and slowly drift time from the real one to the value we really want. And by this, we can, again, reach the same situation. In a certain segment of the network, we can create a deviation from the real time, and the system will stop working. Yeah, that was a practical experience with hacking ICS. So now let's think about how we can improve security of ICS. That's quite interesting thing, because I would probably recommend starting from changing your mindset, because thinking about this, oh yeah, okay, we ask some guys to come and do some tests, and this will be enough. It's a bad idea. Because security is a process, right? It's not one-time event. And someone said that security is a system property, not a feature. So to me, it's very important to understand that it's something which require continuous improvement, continuous refining and learning on mistakes. And here I probably would like to tell you a bit about a thing from a completely different industry, from manufacturing, called the Toyota Way. So the Toyota Way, introduced by actually Toyota Corporation in 2001, if I'm not mistaken, is a methodology of managing complex manufacturing processes and even the whole organization, really. And the key, there are different elements there, and those elements are absolutely fantastic. In my opinion, they are really applicable to IT security, and specifically to security of industrial systems, really. Because some of them are saying, for example, if there is some problem with security, you should not kind of take it with you for a long time. Once it's identified, it should be solved as quickly as practically possible. Another thing is that everyone in the organization has voice about security. So if someone identified a problem, they should be able to say about it, and someone should take care of to deal with this problem. Another thing is, and that's a key element here, is something called continuous improvement. It's about the fact that we're all human and we make mistakes, and even organizations make mistakes. So it's very important that we kind of appreciate this and we learn on our own mistakes. We will not repeat them twice. So this continuous improvement and continuous refining of security, it's a key element. I think it's absolutely perfectly applicable to industrial systems. Obviously, I probably should also say a bit about defense in depth, and I thought it would be easy to illustrate it as a slices of Swiss cheese, right? So we have different protection layers, and none of those layers is ideal, right? All of them have holes, right? And attacks and hackers might actually penetrate those holes. But the more layers we have, the more secure we are, because at certain layer, probably the attack will be stopped or slowed down enough to discourage the attacker. So that's a quite good way to protect our precious industrial systems. Another good approach is to use network segmentation. It's again dependent on the complexity of the system. Obviously, physical segmentation is quite good. Generally, probably would be the best approach, but also virtual network segmentation is a logical separation of network. Splitting them to VLANs with very thorough traffic control is also a good idea. So if we can wrap it up and summarize and say what we can do, how to make ICS and SCADA systems more secure. So first of all, you have to map the network to identify what you've got, what kind of systems, what kind of devices do you have? Do they need to be there? Why therefore? Are you sure you really know why those devices are there? Identify their criticality. Check if those systems really should be there. And maybe you can reduce the attack surface, but just by switching them off, just by switching something which is not necessary, or simplifying it as much as you can. Patching and updating, it's quite important, but it probably would require a separate conversation, because patching in IT world, in ICS world, it's not an easy thing. And very, very important is never assume security. Always have it tested. And that's why people who specialize in this, they should ask also companies and IT security specialists to come and help. That's probably all from my side. So thank you for your attention. And if you have any questions, I'll be more than happy to answer them on chat. Thank you again.
We think about IoT Village as a movement. These devices are being adopted so rapidly that security is not effectively being baked into the development and deployment of those solutions. That puts consumers at risk, that puts businesses at risk, that puts governments at risk. And what we're trying to do is to galvanize a community around solving that problem.
Every time somebody hears IoT, they immediately think, I don't want this in my house. But as time goes by, that choice of having something in your house or not is not really there.
You can walk in the village, you won't feel like you're asking a dumb question, and you'll still walk away learning something no matter what your skill level is or knowledge.
IoT Village provides an opportunity for people to experience security in a very tangible, very real way.
So what ends up happening is I can kill Lisa right now. She's being smothered. She's flatlining, patient monitor's going nuts, she's dead. What's going on at the nurse's station? She's fine. What I'm doing right now is we are replaying recorded data of a healthy patient. So this patient monitor is something you'd see in every hospital room in America probably. The IoT Village seeks to raise awareness of IoT security. We want consumers to be able to make informed decisions, and we want manufacturers to improve their security.
So we put a lot of work into the security on the Bird 2, and we wanted to put it in front of the DEF CON community and see what people were able to do with it. We've learned stuff about our tech that we didn't previously know, and from my perspective, that's phenomenal because we have a really talented team internally, but when we can be educated by people external to the company, it's a big, big win.
We really want to show that we very much welcome the work that security researchers do, and even though we work in a world, a medical device world, that's not as accessible to the people that work in this space, we really value the input that researchers have. We want to show that we love for them to work with us on medical devices and what they can find in it.
Security is a mission-critical part of being a pioneer. And by participating in this, they're able to address some of the challenges that are introduced through innovation.
Building a contest to challenge hackers, at the world's biggest hacker conference, if these guys didn't know what they were doing, this room would be empty.
So IoT Village is awesome. Unfortunately, like a lot of hackers work in these small groups, they don't really share a lot of information because they kind of want to monetize or capitalize off of the information that they have. So being here in IoT Village gives us an opportunity to talk to a bunch of other hackers that we wouldn't normally talk to and share information and kind of like come together as one.
I think it is the best thing since sliced bread, personally. This year we're here at DEF CON helping run a hands-on lab, IoT Hacking 101. How do we get people involved with this? Because it might be intimidating, right? Walking up into a big CTF at a big conference. The idea is that we handhold them all the way through from the basics of firmware analysis right through to discovering a bug and popping a device or two.
I just connected over Netcat. There was nothing fancy, no authentication, anything like that. And this number here is your authentication token. It's a serial number on the device. That's what they're using for authentication. So what we're doing is that we're showing people how we find vulnerabilities in embedded devices. Specifically, I've been targeting NAS devices, and I've been showing how we find vulnerabilities, develop an exploit for it, and exploit it from the attacker's perspective.
IoT Village is the face of IoT security worldwide. They're probably the most preeminent brand when it comes to dealing with IoT security. We have expertise, they have expertise, and we feel that it's more than just a sponsorship, it's more of a partnership in which we share stuff with each other. The visibility that you get from all of these conferences is an amazing thing.
It's only going to get more and more relevant, and the devices are only going to get more and more prevalent. And so I think it's just a great interactive, hands-on experience for people to come and get immersed.
We know that these security challenges that are inherent within connected devices, they're not going away on their own. We're able to make these challenges come alive, to become real, to be tangible. And when we do that, we enable people to participate in being part of the solution.